Now, as we go on to the additional exercises for Section 2 of Chapter 8, I draw your attention to that we had looked at the actual textbook and very quickly went over the steps of deriving the formula from the, over here, quadratic equation by completing the square to get the quadratic formula. So let's do both of these actually. And as we look at this first one, the principle of square roots is if we have x squared equals k, we take the square root of this side and then plus or minus the square root of that side. So x is plus or minus the square root of k. And in the quadratic formula, by completing the square, this becomes negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is the quadratic formula. Now, to use the quadratic formula in any example, we're going to need to know what is b, what is a, it's used in two places, and what is c. Now notice, this is going to be our a, this is going to be our b, and this is going to be our c when it's in standard form. So one of the main things, what we need to do as we use the quadratic formula, is to be sure we have a, b, and c in standard form and not spread out all over the place, as you'll see. So what is a here? Well, a here is going to be 1. We don't write it, but we need a 1 for a. What is b here? Well, b will be a positive 3. And what is c? C is going to be a negative 2. So now we go in and do our substitution. So we're going to say x equals a negative b. Now here we have a positive b, so it's going to be a negative 3. Now an interesting thing happens anytime that b is negative here. We have a negative of a negative b makes this b a positive. But right now it's a negative because it's negative a positive 3, which is negative 3. And then we take the square root of this, and now that we're going to square b, whatever b happened to be, it's always going to become positive now because we're squaring it. So we're going to have 3 squared minus 4, that's part of the formula. A we said was 1, and c we said was negative 2. And this is all over 2a, and we said a is 1. So we get, this is a 9. I'm just doing some calculation here. This is going to be a negative 4 times a negative 2, which gives me a positive 8. 8 plus 9 is 17. Well, there's my answer. Minus 3 plus the square root of 17 divided by 2, or minus 3 minus the square root of 17 divided by 2. How did we get this? We got this through the quadratic formula. Now I'm not going to do them all, because would make the tape very long here. But we're going to go over technique. So what's A, what's B, what's C here? Well, first of all, is that in standard form? And the answer is no. So in order to determine what A, B, and C is, we need to have it in standard form. So I've transposed then the positive 32A. On this side it becomes negative. Transpose the negative 20, it becomes 40. I'm sorry, 20. Thinking of something else. Now, I don't know if the book wanted me to do this or not, but I'm going to show you something. Can you see you can factor out a 4 from each one of these? And this just becomes then A squared minus 8A plus 5 equals 0. Now it's not the same equation, but it's equivalent. So now it makes it a little easier to work. So A will be 1, B is going to be a negative 8, and C is going to be a positive 5. Now, again, we had this. We had to put it in standard form so we could identify our A, B, and C term. I saw that once we put it in standard form, we could factor out a 4, which made the numbers a little smaller. So again, our A term is 1, our B term is negative 8, and our C term is 5. So then I started to put it into the quadratic formula. Well, notice it's a negative B. So there's my negative. Now B itself is a negative 8. So what happens here? Well, the signs change. This will become a positive 8. And I'm going to put it under our common 2 here. So I'm going to square 8. Minus 4 times A, which was 1, times C, which is 5. So this becomes 64, and this becomes 20, a negative 20. And I do the subtraction, and I get a 44 here. And then I take 44, divide it into a 4, times 11. The square root of 4 is 2. This cancels and becomes 4. This cancels out, and all I'm left with is the square root of 11. So our answer then for number 4 is 4 plus or minus the square root of 11. Now, I believe in Math Lab you have to put them in separately, although sometimes they may have these signs together like so. Okay. Now, in this next one, we notice A will be 1, B will be 1, and C is 3. So, X equals a negative B, so negative 1, plus or minus the square root of B squared is 1, minus 4, A is 1, and C is a 3. And that's all going to be over 2A, which makes that 2. So we get x equals -1 plus or minus. Now this is going to be a -12 plus 1. So under the radical sign, I'm going to have a -11. All divided by 2. Well, what we have here then is an imaginary number. So I'm going to write it then. -1 plus or minus I, the square root of 11. And theoretically we should separate that into a 2 there and a 2 there. And instead of the I being there, theoretically we should have the I there. Now that's in the standard form of A plus BI. And of course we'd have to take the I away from there. And let's go on. For number 6 here, again we have to put it in standard form in order to get our A, which will be 1. This is going to come over, and that'll be a -4, so B is a -4. C is going to be 11, and this equals 0. Again, we did one just like that. Let's go on to 7. 7's a little different. Well, as you probably realize by this time, to use the quadratic formula, it's a good general multi-purpose way of solving quadratic equations, but sometimes to get to it is a challenge. So as we look at example 7 here, we want to get rid of our denominators. So our lowest common denominator is x squared. So here the x squares cancel out, and we're just left with the 1. Then here it's -2 times x squared. And then here we're going to cancel one of the x's, and we get 8x. Now I'm trying to identify my A, B, and C term, so I have to put it in standard form. So I'm going to, this is negative, I want it to be positive, so I'm going to transpose it to this side. It becomes a positive 2x plus 8 minus A, minus 1. So this is our A term, this is our B term, and this is our C term. Now notice you've already done a problem just doing that. And now you're going to substitute into the quadratic formula. B is, in this case, a positive 8, so the opposite of a positive 8 is -8. Plus or minus 8 squared, it's always going to be positive, that's 64, minus 4 times A, which we said was 2, times C, which is 1. So this gives me a positive 8, and 64 give me my 72. Now 72, we notice it has a perfect square factor of 36 times the square root of 2. Square root of 36 is 6. That's where this 6 comes from, the square root of 2. And I've put it into two separate terms there. And then this will cancel and become a -2. And I can simplify that a little bit into 3 over 2, the square root of 2. So there's the answer to number 7. But notice it is tedious and it just takes time. Not going to do them all, but we have to recognize what is our A, B, and C. So here we have 4s plus s squared minus 3s equals 1. So we have s squared plus s, 1s, transpose that, negative 1 equals 0. Now we can identify our a, b, and c. Our a is 1, our b is 1, and our c is a negative 1. Put it into the quadratic formula. Again, our a, b, and c here, we have to transpose that to have it equal 0. That becomes a negative 2. So a here is 10, b is 5, and c is a negative 2. Here's one that's in standard form. It's just the big number. A is 100. Now, don't forget, b is a negative 60. So when you put the opposite of b into our formula, the opposite of a negative 60 makes it a positive 60. It's a little point. And then our c is plus 9. So in this, you'd have to distribute, put in standard form accurately, and figure out your a, b, and c. Again, standard form. You may be able to start to do it. This is going to be a is 5, b is going to be a negative 12, and c is going to be a negative 16. Here a is 1, b, when it comes over, will be a negative 6 on this side, and c is a positive 25. Number 14. I'll do that one. Now, as we look at 14, we see the difference of perfect cubes. So that will factor into this and this. I think that's from chapter 5. And equals 0. So we then know that x, so over here we have x minus 5 equals 0, and x will equal a positive 5. But now here we have to put it into the quadratic formula. A is 1, b is 5, and c is 25. So our b is a negative b, which is negative 5. 5 squared is 25 minus 4ac. That gives you a negative 100. So that will give us under the radical a negative 25, which I can factor into these two parts, a negative 25 and a square root of 3. This comes out as a 5i, the square root of 3, over 2. So my final answers then will be a negative 5 halves, and then plus or minus 5i, the square root of 3, over 2. Now I left it that way. Keep in mind the I should actually go out here to put it in standard form. Old habits die slowly. All right, that was a challenge. Now this one, again, I'll help you find out what A, B, and C is. So there's our basic equation in blue. I have to get rid of these fractions. So I'm going to multiply everything by the common denominator. Here the x's cancel out. And I'm left with 4x plus 12. Here this cancels out, and I'm left with just 4x. And then I have to multiply 2 times this, which is actually that. So 2 times that gives me 2x squared plus 6x. Combine like terms, I get an 8x here that I'll transpose. That'll leave me with a negative 2x. I transpose the positive 12, it becomes a negative 12. And then I say, hey, look, I can divide everything by 2. And I get this. And then I said, hey, wait a minute. A is 1, B is negative 1, and C is negative 6. But I can factor that. Now, they don't want us to factor it, but I did, just to show you. And then what are your results? Well, here, x is going to be a negative 2, and y is a 3, and those are the answers. Okay. Now, keep in mind, in your toolbox, you have a number of ways to do quadratic equations. The way, and sort of the easy, if you could see it, is factoring. Then the principle of square roots, where you take the square root. Then we had completing the square. And then we have the quadratic formula. So a number of things going on here. All right, to do number 17, again, what they want here is to use your calculator to approximate to 3 decimal places the solutions. So, interestingly, I have a calculator that does this. I just put in A, B, and C, hit the button, it tells me these answers. Okay, but if you had to work it out, there's your x equals negative b, so that's a negative 2, plus or minus b squared minus 4 times a times c, which comes out to 24. Well, 24, you may recall, is the square root of 4 times the square root of 6. And the square root of 4 is 2. So one answer then would be this. Notice here the 2's cancel out, you get a negative 1. Here the 2's cancel out, you get a 6. Here the 2's cancel out, you get your negative 1. And here you get a negative 6. So if you put that into your calculator, you get this. And this into your calculator, you get this. And again, others are done in a similar way. And we're just a little over 23 minutes. So again, we're trying to show you methods of finding A, B, and C, the proper ones, by putting your quadratic equation into standard form, and then carefully putting it into the quadratic formula. Keeping in mind, sometimes completing the square might be the easier way, or the principle of square roots, or factoring. And that'll wrap this up.